First of all, I'll introduce myself. My name is Andrew. I'm primarily the founder of ArrowStream, which is a research consultancy that specializes in getting data, survey data into tools like Tableau. Recently set up a new venture called Purify Intelligence, which is all about getting survey data into the modern data stack. And then in my extra time, not quite sure where that is, I'm also a director at the Association for Survey Computing, which is where we are today. Earlier in the year, we had our conference over at the Oval, where I presented a talk about how we can now use Python in Excel. It was a quick 20-minute kind of presentation about some of the cool stuff that you can do. And so the purpose of this workshop today is to get into the detail and kind of show you exactly how you can get started. It's kind of an exciting journey. There's so much that can be talked about. So what I thought I would do during this session is kind of really focus on how you guys can get started. I'm guessing there's kind of a mix of skills on this group today. So some people have maybe never touched Python before, but keen to learn more. And then there'll be others who are kind of fairly good and you're very good at Python, but maybe never knew that you could do it in Excel. So hopefully we kind of bridge that gap during today's session. If you do want to connect with me on LinkedIn afterwards, then please do. There's a little link in the workbook. And then also, if you actually just want to have a more of a kind of in-depth chat about a topic, then please just book a meeting with me. And then I'll come to this one a little bit later, but there's plenty more Python Excel examples which I've put together, which are primarily focused on survey research. So I'm hoping that they'll be really useful for you as well. So what I will do, first of all, is kind of just look into actually what is Python and just give a kind of a high level introduction. So it's a programming language which has kind of been around probably about 20 years, but it's largely becoming one of the most popular programming language out there. The reason being is it's fairly easy to read and it's fairly easy to write. And in the advent of AI, it's so much easier to get going. So a lot of the AI tools like ChatGPT or Claude, they're very heavily trained on how to use Python. And so if you have any questions with how do I do this in Python, then those tools are exceptional at getting you started. I wouldn't base all of my code on them because sometimes they do make mistakes, but it really is a great training tool. So Python is kind of inbuilt in so many different things. We're going to be largely focusing on data analysis today, but it can do a whole number of tools as well, different things as well. But I won't jump into all the detail. Primarily, you used to be able to run Python using Python scripts. There used to be also something called Jupyter Notebooks, which also allowed you to write Python and share it. But what I find kind of exciting is that it's now in Excel, which then makes it a lot easier to share, both amongst each other and also with clients and colleagues. So you no longer have to install have a Python set up on your machine or have a Python server at your company. So instead, you can actually just directly start writing Python in Excel, which I think is just great. it just allows us to really get going quite a lot faster. So what I thought I'd do is just kind of go through some basic concepts for those of you who have never used Python before. So what's quite nice about Python is that you don't have to kind of declare variables and things like that. So here I've got a couple. So here I just wanted to create a new variable called name and it equals Andrew. And there's another one of age equals 35. I'm not really 35, I'm a few more years on from that. And a height of 1.8. So then this is also a good time to start introducing how we do it in Excel. So to do that, we literally just take any Excel cell and we write equals pi. And then we open those brackets and then you'll see that that cell changes. And this is now a Python editor. And so we can actually then write Python code in here. So if I start doing that, name equals Andrew, and then just press Control Enter, and then that's now running that Python script in the background, and it's declared this variable name equals Andrew. So that's how quick it is to start writing Python in Excel. And feel free to do this if you've downloaded the workbook, and you can do the same thing. So there's also many other different kind of concepts in Python. I'm not going to go through them all because there's lots. So just a real kind of big overview of kind of the key ones that you need. So there's one called lists, which allows you to store a list of objects in a list, and then there's dictionaries, which allow you to kind of store like key value pairs as an object, and then there's also sets, which is a unique unordered items, kind of similar to a list. We then have things like if statements, as you would expect in these tools, and then loops, which also just allow you to kind of loop through things as you would expect. So again, if we wanted to try some of these, so kind of a quick way which I'd like to do is, let's just take this code here. I'm just going to overwrite this one and put it here, just copy it. And then up here in the formula bar, I'm just going to write equals py open brackets. And as you can see, it's added that Python interpreter again and wrapped it around the text that we've got. And I'm just going to press Control Enter because that's the quick way. And it's then put that code in there. What it's done is actually reported back the last item that it's put in. So we've got that 1.8. So then as we go down here, we can do the same with all of these if we want to. So let's just put them all in here. And so now we're going to declare our list. So that's in here. Press Control Enter. I think I've actually copied them all down in the same thing. That was silly. So let's just do one at a time because that's a bit safer. There we go. And let's then do this if statement as well. So this one has come up with an error, which is always good to see because then we can actually start digging into what's going on. So let's get help on this error. Why is it doing this? The good thing about a live demo is that things can go wrong. Here we go. So up along here, let's see if we can get into this a bit more. This is kind of unplanned, so you have to bear with me a sec. Da-da-da-da. All that. Right, I'm just going to pass on because it's not a good use of my time. But what you can see, there's loads of things that you can do to write your Python code. Now, one of the important things to do is when you're writing these different types of code is that you can import libraries, and these libraries allow you to do different and more powerful things. So the most common one that we use in data analysis is one called pandas. Those that have used Python before, and it's particularly data analysis, you'll know that pandas is one of the most common ones that you use. And so it's a really good way of kind of declaring tables in your code and doing lots of manipulations on them. I looked up why it's called pandas. It's called Python and data science. So it's just that's why it's called pandas. My wife always found it bizarre that I was reading a book about pandas, but that's where it's come from. And then the most common thing that you do within pandas is create these data frames. And a data frame is, in essence, a table of data. it has columns, it has rows. You can then extend it quite a lot. And again, I can't go into the detail. There's a large book that I have, which you can kind of see. It's a very large book all about how to use pandas and data analysis. I just do not have the time to go through that right now, but it's all there for you to have a look into. And then one of the kind of the more useful things about, and the specific thing about using Python and Excel, is that we can actually then start to take data and information that's in our Excel spreadsheet and import that into our Python workbook. And to do that, I've got an example piece of code here. So if we were to do equals pi again, and I want to create a new variable called table, I can then click anywhere and it will then take in that cell reference. So that's then how I import data. And those of you who are kind of fairly familiar with kind of modern Excel, is that they have this concept of tables. And so this kind of worksheet which I'm looking at the moment has a table here. And as you see, as I kind of move up here, this is saying A8 to C22, which is like an old-fashioned cell reference. But if I select the entire table, it will take the name of my table and declare that as a table. So the benefit of doing it with tables is that as that table grows, the Python code will reference that entire table. So if you have a table of information which is growing with more rows or even more columns, then it will extend automatically, which then makes your code a lot better. So then if I just say that there, so this is going to return that object called a data frame, and then that's stored in here. So this brings me on to this next line, which again is a kind of an important concept about using Python in Excel. And that's that you can either export the item as that Python object, or if it's valid, the actual Excel. And so you do that in this very top corner here. So here it's exporting as a Python object, but if we were to change that to Excel value, then it will actually repeat that entire table that we've put into the code. So you can see this is actually the same table that we had here. And it's kind of live linking as well. So if I was to change this just to say Andrew was here, so you can see then that there was a refresh on that Python on those cells. And then down here, I've got the item Andrew was here. So it's then got that live link as you would typically expect in an Excel spreadsheet. One of the important things that we need to kind of be aware of as well is Python and Excel is a little bit different to the way that a typical Excel spreadsheet works. So in normal Excel, you can reference cells all over the place and you can link them together. With Python, you have to structure your workbook like it's a book. So you put your cells from left to right and then top to bottom. What that means is that if you were to write a piece of code here, so equals pi name equals Andrew, and then press return, I can then reference that same variable that I've declared here. And so it will bring back that name Andrew. But if I put it above it, it shouldn't know that it exists. Oh, I think I've called the same thing up here. What a bad example. One sec. So let's call this name number 1. And then call that name number 1. So now it doesn't know that that variable exists. So you have to structure your Python like a book. So left to right, top to bottom. Otherwise it gets confused, and also it just confuses yourself. So just bear that in mind when you're writing your code. So write it in a good structure and it will make your life a lot easier. So other things regarding Python, there's some great kind of initial support from Microsoft in terms of how to get started. So I've provided a link to that here, and that will take you to their own website. So let's just put that on the screen just to give you a quick overview. And this will cover things like how to initially get started, but kind of more importantly, the security, the availability, like where is your code running? Because you may have clients or work that you don't want to be shared amongst the world. And so you can then look on the data security aspect and actually understand how that data is being processed and where it's being run. It's not being run on your computer, it's being run in the Microsoft servers. So it's something to be aware of if you're doing very sensitive data analysis. But yeah, it gives you kind of some really good examples of how to get started. I mentioned earlier that Python's really good at when you use other libraries. And because the installation of your Python is actually hosted by someone else, you can't actually import more libraries than are already in existence on that server. So if you had your own Python library that you wanted to use, if it's not already installed on the Microsoft version, then you can't use it. And so what I've done here is actually just listed all of the Python libraries which are useful. This is actually directly from the website which I showed you earlier. So open source Python libraries. There's the list down here. So I've just copied it into our Excel just for the benefit of all being in one place. And you can see, if you're familiar with Python, you can see some of the libraries, and some of them may be familiar with for you. Some of the most common ones that you will use for data analysis is pandas. NumPy is another very common one. Pillow is good for creating images. And then as we scroll down a bit, you've got some machine learning libraries in here. I've got some examples which I can show you a bit later. Seaborn is very good for data visualization. That's common used with another one called matplotlib. I find that Python libraries always have these really bizarre names, and there's no kind of quick way to understand what they all mean other than just clicking on them and learning about them. Sorry, there's no kind of cheat sheet for that. So I mean, there's one here called Beautiful Soup. I mean, it's just a bizarre kind of name for a Python library, but it's really good at kind of scraping web documents and analyzing HTML. But unless you know that, you're not going to know it from the name. So you just kind of have to get into the detail a little bit more. The one we're going to look at today is word cloud, because I think that's a really nice little example that we could probably all use quite frequently and quite commonly in survey analysis. So that's what we're going to do. So on the next tab, and if you're following along, then you can actually do the code with me. I've got an example that we can play with. So in this example, I've got some comments data. It's all fake, it's all just made up. I think it was actually made up by ChatGPT. I said, give me 25 comments which I can use all about a coffee shop. And so these are those comments. And what we want to do is actually build a word cloud, which allows us to kind of visualize the data that's in those comments. And so we'll go through that part. Now, one of the things with word clouds is that there's this concept called stop words, and stop words are words that you do not want to show in your word cloud. And what I've done for this initial example is put in the word coffee, because if you're a coffee shop and you've asked people about what they think about coffee, the word coffee is going to appear quite a lot, but it's going to be quite a useless piece of information to have in your word cloud. And so that's where we've added this kind of stop words concept. Each of these are then stored as tables. So if we go up to table design, you can see this one here is called word cloud comments table. And then the stop word one is called the word clouds stop words table. So hopefully they've got nice, easy to remember names for us. And then if we scroll down, what I've done is pre-prepared a lot of the Python code that we need to run this. And I'm going to kind of try and talk through each one of these steps so that you can see how it's pulling together. As I mentioned before, I'm going from that top to bottom, left to right, as if we're reading a book kind of structure. So it's one, it's just easy to follow for us, but two, it will work. If you mix them around, it kind of gets a bit confused. So let's start doing that. So if you are following along, I find the easiest way to do this is to literally copy the cell into the text into the cell here, and then just write py open brackets. What it then does is interprets that. You can see it's kind of highlighted some of the words in different colors, and so you can kind of see how that data is structured. So that first thing hasn't actually returned anything. All it's doing is importing the libraries that we need. And the key libraries that we need for this one is that one called matplotlib. So that's our charting visualization library. So that allows us to display the word cloud. And then there's this other library called word cloud, which is an open source library, which makes the process of actually pulling together a word cloud really simple. It's taken all of the hard work out of it for us, which is great. As we've done that, so it's imported this item called word cloud, but it's also got this item called stop words, and they've got a bulk load of common stop words that you don't want. So like your A's, your words that you just don't want to have in your word cloud. So it's already got a kind of a pre-built list for us. Fantastic. So if we then move down to this next item, let's jump into this a little bit more. So what we're going to do now is actually load these tables of data into Python. So we can do, let's just make this a little bit bigger. So up here, I'm just going to then wrap around the Python formula here so that it's then declared it, and then press tick. So what we've done here is imported those stop words in this first instance. So these stop words here, it's just a list of one at the moment, and converted that into a data frame. And then what we've done with that data frame is turned it into a list. So if you remember, we had a list on the other page here, and it was one of our common items here. So here's a list. So now we have a list of those. We have a list, an object called list stop words, which is literally the contents of this table. And because the default way that Python in Excel imports tables, it's always a data frame. But the way that the word clouds tool works is that it wants it as a list. So that's the kind of a little bit of the detail behind that. What we're then doing on this part is then importing the comments. So it almost looks identical in terms of the structure. It's just referencing a different place. So let's import that part as well. So that's going to take the list of comments, the table of comments, put it into a data frame, and then it's going to convert that data frame into a list. And that's done as well. Hopefully you guys are all following along if you are wanting to. Fab. So then what we're then going to do is take the generic list of stop words that this library provides, and then we're going to add the facility to add our own stop words in that as well. So add that coffee entry into it. So that's what this little bit of code here does. So we can again copy that into here. I'm going to put the Python, I forgot my equals at the start. So this has kind of saved it as a set object. And as I mentioned earlier, we can then look at these rather than as the Python object of it's a set, which is not very useful to see. We can put in Excel value, and then it will actually give us the list of all the stop words it's now using. So it's taking these out of our word cloud. So I'd, doesn't, these, who. So words that you just really just don't want to have into your word cloud. It's just provided you with the full list here. And you can add to this, you can even remove some of these if you want to. So if there are words that actually I'd like the word doesn't in my word cloud, then you can remove that if you want to. This makes my code look really messy, so I'm going to convert it back to the Python object so that it's nice and simple. So we've now got our list of stop words and our custom stop words all in one place. And then this next thing that we're going to do is actually put all of the comments that we've got in this item as one big long piece of text. Because the way that the word cloud tool works is that it's going to analyze that one big piece of text and then create the word cloud based on the frequencies and make the most frequent words bigger and that kind of thing. So it has to store it all as one piece of text. So that's what this next little bit of code will do. So combine the comments, and then it's just using a space separator between each one of the comments in the list. So again, this is kind of pure Python, and if you're new to Python, then this is not going to make much sense to you, but hopefully you can see that it's fairly easy to read even if you don't know Python. So let's add that one in. So here you can see it's then created this very long piece of text which has actually concatenated all of the items together. Moving on then, so we've now got our big list of text. We've got our stop words set as an object. So now we can actually build the word cloud object using the word cloud library. And that's what this little bit of code here does. So let's take that like we've done before, and then put an equals py around here and press tick. So here it's now created this word cloud object. So what it's done, it's taken in our, if we read this here, it's taken in our custom stop words and applied that to the word cloud. And then it's also taken our list, our combined comments, so that's our really long string of text, and generated the word cloud. But it's only created the object of a word cloud. It needs now to be told to present it. And that's where we've used that matplotlib library that we said before to actually then display what that word cloud looks like. And so that's where we take this little bit of code, put the equals, where's that gone? Equals py around it. I done. It's not playing ball with me today. And as you can see here, it's now saying image. And then what we can do is that we want to look at this as the Excel value rather than the item. And it's now generated that image actually in the cell. Now the cell is quite small, so it's not a very useful place to be. But as you can see, when we've done that, it's got this little tooltip extra button that's appeared at the top here, and we can then make it an image. So here we now have kind of an image which you can then save as picture or copy or put into your PowerPoint presentation, which is a word cloud of the data that we've got up here, which I think is quite cool. So if I then let's just move this up. So let's just zoom out a little bit and then move this up to the top. Come on. Okay, so now we have our word cloud, and then we've got our stop words here. So let's say I don't really want the word make in my word cloud, so I'm going to add the word make into my stop words. And then it should be regenerating that Excel now. and then it's removed the word make. So because this is using that table concept which I said at the start, it will automatically extend as that table grows as well. So if we then want to extend this to then remove the word great, great's quite a good one. Let's take the word drink out, because that's also kind of a useless concept. And so you can see it's just automatically generating that word cloud. So it's running that all of these Python steps all as one process to then give you your output at the bottom. Pretty cool, huh? Now here I've separated, just for the purpose of this talk, every single step, but there's nothing to say that you can't put all of this text, all of this Python script into one single cell. It will be harder to debug, but it will mean that you don't have to take up all of these rows of data in your spreadsheet to explain how the Python code works. So you could list all of these things on top of each other and it will work in exactly the same way. It's also very customizable. So if we go back to this one here, you can see that I've got a background here, background color of white. If I was to change that to black, and then scroll up to the top once it's finished processing it. Oh no, I've edited the text and not the actual Python code. That's silly. So you can see it's doing this kind of whirly thing in the cell, and now we've got a black background. You could replace that with any hex code. So if you've got a particular brand style that you want as a background, then you can change that. So there's loads of different options that you can do. And then something which I found yesterday, the day before that, when I was exploring this, is that you can, so that by default, it will create it as a nice little rectangle, which is okay. But what I found is that you can actually then put it in different shapes if you needed to. This code here, if you unhide some of the cells, if you've downloaded the workbook, it's kind of a little hidden thing which I pulled together. So I'm just going to wrap this around some Python code. This is getting a little bit complicated, but what it's doing is kind of building the shapes and how to create the images for you. You don't need to know the detail too much. And then in this one, this is going to build the word cloud with the different shape masks on them. So if we then put py on this, it will then build it, but taking this as a reference of square and building the image. So then let's convert that to the image. Let's make this a little bit smaller. I don't need it that big. And here we've now got our word cloud as a square. If we were to change it, I've also got a circle. And so it will make it round. Or if you want it as an ellipse, then you've got these options here. So yeah, you can then really kind of get a little bit kind of more creative in the way that you design your word clouds. It's like triangle's not working. Okay, before I go on to explain some of the other things, are there any questions on the chat or that anybody has in where we've got to so far? No, not yet. Fab. I'll take the silence of everyone has kind of fully understood everything that's going on. If you haven't and you don't want to admit it, I am recording this entire session, and so you can go back and see the code. The code is here, so it's your workbook now. Feel free to use it as you like. But hopefully I'm hoping that you can just use this workbook again and again, extend it to your specific needs, and then you've always got a word cloud creator if you ever need one. Fantastic. So what I wanted to do next is just kind of show you some of the other examples that I pulled together initially for the presentation that was delivered for the ASC conference, but also where it's potentially going, and then this may kind of give you some more inspiration for what you could do for your research analysis. So if you go back to this front page and then click on Get More Python in Excel Examples, you will come to my GitHub page. And in here, if you scroll down a little bit, because it's got a list of all the items in here, but in here you'll see all the different examples which I've created so far. They're all completely free to use, so feel free to use them. So we've got one here which is the word cloud. So that training version which you've downloaded and we've went through just now is available here. If you don't want the training version, you just want the complete version, then you've got the word cloud complete version here. And then there's loads of other examples. Now, I haven't gone through these examples in the same level of detail as that training example because that was a training example. But you can then look at how these specific ones are working. So there's one here which is bar chart with sig arrows. So if I click onto this and I download the file, let's open that up. So this was actually the first example that I ever did using Python in Excel. And what we wanted to do is something that's very common, it seems, in market research, is put the little significant differences arrows on top of charts. But anyone that's done this in Excel and tried to use the chart feature to put those little arrows on top will appreciate that it's a really hard thing to do, and it's very fiddly. And I've seen some clients, they literally manually put those little triangles on top. And so I thought, well, can we use Python and Excel to actually draw the chart for us automatically and then add in those triangles, the little up arrows and little down arrows as we need it. And then also, sometimes we have a low base size. So could we indicate that on the chart as well, so that it's all kind of just encapsulated and you don't have to fiddle around with all the chart wizards that are in Excel. So that's exactly what this does. So here we've got our table of data. We've got our different percentages here. And if the, let's just enable editing on that. If the significance is 1, then it will give it a little up arrow. If it's a -1, then it's a down arrow. And if it's 0, it's nothing. So I can then change this, change that to a 1, and you can see that I then got my little up arrow. So it's very simple, but it's kind of streamlined a lot of the pain of creating these charts. The code for it is in here. So like I mentioned in that previous example, rather than separating every little bit of Python code into a separate cell, I put them all into one. So here, this first part is importing the libraries that we need. Here it's then calling the data frame, so it's calling this table here. I then extended it, so it's actually then taking the hex code of the colors that we want to use, so that you're not actually manually picking from a chart wizard. Instead, you can just reference it here. So if I changed the items here, let's put B3 in here. I don't know if people know the hex codes off by heart, but you can then see that the chart has changed color. So again, if you've got your own brand book and you want to use very specific colors and the hex codes, or your client does, and you don't want to go into every single chart that you've created and manually change them, then you could do that within the Python that you have. Got one here for the title as well, so you can change that. So here, there's that Python code, and so you can extend Python as you see fit. So that's another example. So if we then just go back to the list of items that we had, so let's just come back here. Some other more kind of useful ones, I think, for survey research. One I did most recently was rim weighting. So doing survey weights is a common tool that we do. So let's do that. So here I've got my kind of classic survey data, and I've just picked the first couple of columns. It's all made up fake data. So we've got an ID here, the gender, and then the age group. And then we wanted some target weights here. So I wanted 48% male, 52% female, and then I wanted these age groups in there as well. And so we can just do what I call kind of blunt weighting, where it's just taking these proportions and creating a blunt weight. So it's doing it really kind of crudely. But then those of you who know about kind of rim weighting or rake weighting will know that if you can refine those a little bit more so that your weights don't kind of are not so skewed and not so extreme. And so that's what we've done here. So this first bit of code here is importing those tables that we had. So importing the target weights here for the gender, importing the target weights for the age. And then this next one, this here is the rim weighting function. So it's a iterative function, so it will run over it multiple times. The number of times I've actually set as a parameter, which you can change. And so that will then give you the different, so here's the blunt weighting and here's the rim weighting. And so you can see that just kind of eyeballing it, sorry, let's just make this a bit smaller. Just eyeballing this, you can see that the weights aren't as extreme. And so I then did some further analysis here to kind of look at the quality of the weighting that you've done. So doing effective sample size, your mins, your maxes, your means. So here we can see that the min and max for the rim weighting, the extremes are a lot smaller. The effective sample size is closer to the original base size, which is good. The standard deviation is lower, the coefficient of variation is lower, the design effect is closer to 1. So that's a rim weighting. So prior to Python and Excel, I think, and people please correct me if I'm wrong, you had to use kind of specialist software to do rim weighting, but now you can do it directly in Excel because you've got Python in Excel. Fab. So there's, as I mentioned, there's so many examples which I've pulled together in here, but there's also loads which are yet to be discovered. So if anyone on this call here today has got examples, or would it be great if we could, then please do get in touch. Even on this chat now, if you've got it, wouldn't it be great if we could do this? I'm really keen to kind of get under the skin of how these kind of algorithms work and then make them more readily available for all of us. So just looking down this list, again, I don't have time to go into all of them now. So I've got some here example charts. So if you need to do radar charts or heat maps, then you can do those. Sentiment analysis. So if you've got open-end text, there's a really nice Python library called Vader, which was developed to analyze tweets. And so it will then determine whether that tweet is positive or negative. It doesn't always understand sarcasm, but it's a good kind of first pass at sentiment. And so in survey analysis, we do a lot of open-end coding. And are people saying something positive or something negative? And this allows you to have that first pass. So if you put in your open-end text comments, you can then do your sentiment analysis. Is it good or bad? So that's quite interesting. This polar histogram, I'll open that up because it's an extreme example of what you can now do. So the chart library can be created to do these weird and wonderful things. Now I can't say that I came up with this. It's the Python for it is extensive, to be honest, but it's there, it's then created, and then you can adapt it. So if you don't like the color of it, you can change it. If you don't like the data that's going in, you can change it. The full code is here, so you can then see all the code that runs it. So if you wanted to create something like this for your analysis or for your work, then you can adapt this code here. So let's come back to the list of items here. I'll come to that in a moment. Where are we? There's a QR code generator that you can now do in Excel. Yeah, sentiment analysis we've discussed. Sorry, I'm going down the wrong list. I did an example of how synthetic data is created, which is machine learning. So filling in missing gaps in your survey data. There's loads. So feel free to use it. And I mentioned when I talked about this workshop is like how you can take advantage of AI to do these things. And it's kind of using AI is how I've learned how to do several of the things which are in this library of different tools. So if we come back to that initial list of what Python libraries do we actually have in Excel. So here there's the top one here is all about astronomy. And it's just like, I've never heard of this, literally never heard of it at all. And I don't even know what it is. So I thought, well, could someone give me an example? And so I can go to their webpage and kind of, it will tell me what this is about. But to be honest, it's still in a bit of a language which I just don't understand. So I'm like, I don't know what to do with this. So what I then did is I went to Claude, the AI. I'm using the free version here. And I said, can you give me an example of using a Stropy Python package? And it went, yeah, sure. Here's a simple example of how to use this. And then here is all the code. So I took all this, I copied it. And because this is a library which is already in our Excel, I can then go in here, equals py, open, copy. And then for me, I'm a very pragmatic, I like to see and I want to see how these things work. And so here it's come up with none because of the way that this has worked. It's printing the answers. But if we look on the Python editor here, let's just fix this to the current sheet. On the side here, you can see that code, and then underneath, it's telling us what each one of those things are doing. So it's really going into the nth degree about different calculations which are using in astronomy and when you're working with the stars. But it's a really nice example of how you can then take use AI to help you learn how these Python tools work. There's not that many examples out there which are Python in Excel. And if you Google it, Python and Excel are such common words that you'll tend to get a lot of Python scripts which will generate Excel for you, which isn't quite what we're trying to do. What we're trying to do is have Python in Excel. And so that's where I feel that you need to kind of be quite creative in how you learn how to use Python and Excel. Fab. I've got 10 minutes before the end of this session. Does anybody want to cut off the microphone and ask any questions or put any questions in the chat?
I put a question in chat. I don't know if you can see it.
Yes. So will Python code work across different worksheets if my data is in a different sheet to the code? Yes. But it's still in that kind of same concept that I said at the start, like reading a book. So if you, so I think we still have up here, here I declared this variable called name equals Andrew. Now, if I went to the sheet before and put in here equals pi name, enter, it's not going to understand it. It's going to get it's come up with a little error here saying name is not defined. But if I took that code and put it in a new sheet after that one, then it will work. So that's now returned the word Andrew. So you have to structure your Excel workbook in the like a book. So left to right, top to bottom, and then in the order of sheets as well, left to right. What is fairly common with people who are using Python Excel is that they'll declare all of their Python in a sheet, which will have all of the detail like this, like separated out, and then they'll hide that in the first sheet of their workbook. And because it's in the first sheet of their workbook, it's hidden, it's at the start. So the rest of the workbook will always have all of the, you'll be able to reference it if you need to. Hopefully that answers your question.
It does, thank you. And there's another question come up as well.
Fab. Can you write Python code into an Excel cell from an external program? I'm not sure what you mean. Can you elaborate a little bit more, Phil?
Yeah, what I was thinking was that obviously you can output a table or anything else you like from an external program by dropping it into an Excel spreadsheet. If you wanted to put some some Python code into Excel so that someone else could then run some Python script you think would be useful for them, could you output that from another program by just dropping it into a cell? Like you could put a 1 in column A in cell A1 if you wanted to.
So I suppose Python Excel only works in Excel. So you wouldn't be able to reference like another application outside of Excel. So it'll only work in that controlled environment. What you can do, if you're familiar with it, is in data, there's Power Query is built into Excel now. So if you did have data in another file or another database and you wanted to, you can pull that data into Excel using Power Query, and then you can apply the Python scripts to that table which has come in from Power Query. Hopefully that makes sense.
Yeah, sort of. Yeah.
The thing that I think you need to realize is that if you're familiar with Python, you'll realize that you'll kind of hit a roadblock with what you can do in Excel, because you can't control the environment. You can't add your own libraries. You can't reference external things. You can't reference other files on your computer because it's just a really small controlled environment. So, but if you're new to Python, it allows you to learn Python really quickly and in a safe place. But at the point when you go, I need to do these extra things, then that's where you need to kind of move away from Excel in Python and then do them in an external Python environment. Another example, even with this word cloud one, is that you can, where I did this example here, where you can change the shape. In the proper version of the word cloud tool, you can actually import an image, and then it will create a mask of the image. So let's say you've got a logo or I don't know, a picture of a violin. My wife plays the violin. You had a picture of a violin. You could then put a word cloud in the shape of the violin if you kind of set the transparent backgrounds and things. But you can't import images into Excel, or at least not easily. There is a way, but I won't go into it. And so there's more that you can do outside of Excel of Python and Excel if you just went to pure Python. So it's something to bear in mind if you hit a block. Any other questions?
Just not a question, unless anyone else is thinking, but just a comment. It seems to me that as a very beginner Python user, this is a great way to sort of feel your way. If you're confident in Excel, you can feel your way around Python and start learning more and better Python this way, which I find interesting.
Yeah, 100%. I think when I first started to learn Python, and I got my book, my Python for Data Analysis book, which I got from the shop, the first chapter is setting up your environment and going through all of the settings and all this kind of stuff. And it almost put me off doing it because, you know, something didn't work, or the book was written in an old version of Python to what my computer now has. But now that you have Python Excel, you can just start writing it. And, you know, if you see an interesting blog article about Python code and what someone's done, which is where that polar histogram came from, I saw someone had done it and I thought, oh, I wonder if I can put that in Excel. And boom, it was done. Then it just breaks down those boundaries, which is great. And then you can share it with people as well, like I'm sharing these with you.
Yeah, no, I had exactly the same experience. I used it's a great book, Automate the Boring Stuff with Python, it's called, which is a brilliant book if anyone wants to get into, that's the one, if anyone wants to get into Python. But like you, I felt the environment and just trying to do something very basic and all the stuff around debugging different rows, and yeah, no, it's great.
Fab. Thanks, Nikki. Anyone else have any questions, comments, or thoughts before we wrap this up? No. Okay, fine. No problem at all. So as I mentioned at the very start, if this has been interesting, do reach out to me on LinkedIn. It'd be great to catch up. If you have a tricky example or something that you're trying to work with, or you just get stuck, then please feel free to book a meeting with me. Just click on here and you can set up even just a 15-minute chat to go, how do I do this? I'm always open for a chat. So do that. And then finally, if you do have if you just want to see some more examples of what you can do, then please use this resource. If you've got more examples, you've created something and you want to add it to the resource, then please do. As I mentioned, these are all, I put it as a MIT license, which allows you to freely use it and adapt it and take advantage of it. So feel free to do that. Fantastic. So today's session is what we call a ASC Labs session. So it's a new concept which we've developed for the ASC, where we just explore new concepts. We run them every month. Next month we've got another one which would actually just be a coffee morning, which is just a chat. It's not recorded, so if you do have, if you just want to kind of catch up with people who understand what weighting schemas mean and the ins and outs of MaxDiff, then feel free to join the conversation and we just have a cup of coffee and a chinwag. So that's what we're doing at the next one in August. I'll send an email to you all so you can find out more details and sign up if you want to. But other than that, that's it. Thank you very much for your time. Enjoy the rest of your Friday. Thank you.